Preparing for what comes next is a big part of becoming an adult. So, if your teenager says they want to join the military, they're preparing for a real challenge. Visit todaysmilitary.com because their success tomorrow begins with your support today.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello once again and welcome to the Space Nuts podcast, episode 263. My name's Andrew Dunkley, your host, and today on the program, a warning from NASA that the moon is approaching a cycle that, when combined with climate change, might see some high tides exceeding flood thresholds. And they're not talking the distant future either. It's pretty soon. And the InSight mission on Mars has revealed clues about Mars Quakes and the core of the red planet. They think they've got that figured out, and it's quite astounding. Plus audience questions. We'll hear from Ollie in South Australia. He wants to know what knocked Uranus flat on its back and where that thing is now. And Matt from Chattanooga is asking questions about that recent Virgin Galactic flight and how they attained zero G, and was it a free fall or something to that effect, and the whys and wherefores of the trip. So we will revisit that. As usual, joining me is astronomer at large, Professor Fred Watson. Hello, Fred.
Hi, Andrew. Good morning. It is morning as we record this, so I can say good morning.
Yes, it is. Yes. Now, I'm at a different location today. Do you love my teal wall?
It looks like a green screen. Yeah, it looks like a green screen that for you getting a good background on TV there. Yeah, it's very nice.
Yeah, it does, doesn't it? It's just somebody painted the entire office that I work in teal. If I turned the camera around and showed you every wall in the place, they'd all be that colour.
Yeah,
it's rather dreadful. But anyway, we carry on regardless. Now, Fred, how are you going with lockdown and isolation?
Yeah, we're still in isolation here, thanks to going to buy a bottle of milk in the wrong shop at the wrong time a week last Saturday. It turned out that that particular Woolworths was a contact point. It turned into a hotspot, which means that we got pinged by New South Wales and said, yeah, you're in isolation now, mate. Get tested twice more. In fact, we'd been tested 3 times altogether. The final one's tomorrow. But out of lockdown at the weekend, out of isolation at the weekend. However, the Sydney area is still in lockdown, and we're just hearing this morning reports of cases of COVID-19 in our local area, which is even nearer than where we were before. So we'll be out of isolation with nowhere to go, Andrew.
That's unfortunately the case, and my boys are down there as well, and they've been locked up for quite a while now, and they've got a bit longer to wait. They're very lucky, though, that they can work from home, so they can at least keep themselves fairly occupied. But this outbreak is just not showing any signs of winding back, and that's the tragedy of it. So hopefully they'll haul it all in. And things will get back to normal soon, but at the moment it's terrible.
Yep.
Okay, Fred, let's get down to business. We'll start off with this warning from NASA that the moon is approaching a cycle which, when combined with the climate change issues that the planet is facing, will see high tides exceeding flooding thresholds in some parts of the world. Now, they're talking the mid-2030s. This is quite astonishing.
Yes, that's right. It's nothing new as far as the astronomy is concerned. What we've got is a situation where astronomy and climate change are coming together, if I can put it that way. So the moon, it goes through various cycles. The one we all know is the monthly cycle. That's why we call it a month, because once a month the moon goes round in its orbit around the Earth. But the orbit itself undergoes other cycles as well. And in particular, there is an 18.6-year cycle that is to do with the precession of the moon's orbit. Now, I think we've talked about the precession of the Earth's axis before, and that's something easy to understand. If you think of the Earth as a big spinning top, it's spinning, rotates once every 24 hours, but its axis is also rotating around, just like a spinning tops does, and that's called precession. In the case of the Earth's axis, it goes around once in 26,000 years, so it's a much longer period phenomenon. But the Moon's orbit around the Earth does that too. If you think of the orbit as being in a flat plane, and then imagine a perpendicular to that plane, it's that perpendicular that's precessing very slightly around a pole, a bit like the Earth's axis does, and that's an 18.6 year cycle. And what it does is it changes the Moon's orbit, not by much. It's certainly nothing you'd notice with the naked eye, but it changes it enough to affect the Moon's influence on the tides on Earth. And so what happens is that sometimes during that 18.6 year cycle, you get high tides being a bit lower and low tides being a bit higher, which means the range is getting smaller. But at other times, kind of, the other half of the cycle, if I can put it that way, the high tides are higher and the low tides are lower. And that's what NASA scientists, along with scientists in the University of Hawaii, have raised an alert on, not to be alarmist, but to make the point that what this has, its practical effect is that low-lying coastal areas will have more of these things that are sometimes called nuisance floods where you've got a really high tide, and it floods the streets of the coastal areas. There will be more of those. That's the point that they're making, and in particular, this is likely to be the case from the mid-2030s. For a few years. And so what they're saying is not, this is a terrible situation, we're all going to die. It's not that. It's about advising city planners and local authorities that look after the flood protection on coastlines and things of that sort. All of these people who need to know that we're likely to see more of these events in the 2030s.
What about low-lying places like the Maldives that are only like 1 or 2 meters above sea level? What sort of an impact would it have on places like that?
Yes, exactly. So there are also places that are at risk because you might not get. It won't be dramatically that much higher than it is now, but it'll be more often. It might be. It's probably still a fraction of a meter that we're talking about, the difference, but it will happen more often.
Okay.
We've
heard of king tides happening.
And that's
fairly
the kind
regularly.
of thing we're talking about. Yeah.
Right. So bigger king tides is what we're talking about.
That's exactly it. So. Technically, a king tide. So a spring tide is when the moon and the sun basically are in the same direction. So you get higher and lower tides. A king tide usually is that combined with meteorological effects, which if you get a low pressure region, then the tide comes up higher. So you get these king tides. It's nothing like a tsunami. It's not that kind of thing we're talking about. It's just an increase in the tidal range. What I guess concerns me or interests me about this is that with sea level rise, that is a process that's going to continue for a very long time. So when we get to the next phase of the moon's precessional period, which will be in the 2050s, we're probably going to get even more effects from this. So the 2050s, we're going to see much more of these coastal intrusions of water. So it's a good warning. It's actually come from ocean scientists as well as astronomers. This work, it's been done very careful work. It's easy to find the reports on it. They've taken the results from many oceanographic studies and folded them into what we know about the effect of tides and the moon's orbit. So it's a well meant and well placed warning.
Yes, indeed. And it looks like their projections go right out to about 2080. So they've got a pretty good idea of what's going to happen. I would imagine that if you're in the 2030s and one of these, super king tides, I suppose they'll end up calling them in journalism, starts to happen at the same time as you get a massive low pressure system and a tropical storm of some kind in the same area, I can imagine what that would do.
That's right. Let's
hope that doesn't happen.
Yeah, exactly.
All right. Very interesting stuff. And you can actually look up that paper. I think it's available through NASA. It's widely published, so it shouldn't be difficult to find. By the by, Fred, I used to live in Mackay in North Queensland. Judy and I moved up there just after we got married. Now, they have king tides. They have playing fields around some of the beaches there, and quite often they'll go a couple of feet underwater when they have a big tide. Yeah. And the real interesting thing that they've done in Mackay to try and alleviate some of these tidal surges is that they have built channels in the city that when you get a big tide comes in, the channels fill up so the land doesn't go under. We used to live in a house that had these channels behind them, and it sometimes was full to the brim of seawater.
Wow.
And then 6 hours later, it was empty. It was fascinating, quite fascinating.
Be a bit scary as well.
Well, that's how some places. Yeah. Especially because it moves so fast. When the tide's going out, that water actually goes in a rush. Yeah. And it's a different world up there. I mean, I grew up around the Newcastle area where the tides were pretty mild. Meagre would be the word, and to be the same in Sydney. But up in Mackay, you could actually walk with the incoming tide.
Oh, weird.
It was really fascinating. Very slow walking pace, but it came in that fast. So, and I know there are other parts of the world where it actually comes in like a wave. So, it's really, I find that kind of influence of things like the moon on our waterways here just quite intriguing. I do find it amazing. And I've witnessed some pretty amazing tides and king tides over the years too. You are listening to the Space Nuts podcast with Andrew Dunkley and the good Professor Fred Watson.
Roger, you're loud and clear here also.
Space Nuts.
Thanks to our supporters who put a bit of money in the can every week. We've actually got a physical can on my door. So if you're a Space Nuts follower and you want to put a couple of dollars in there to support us, that's what it's for. An easier way for those who aren't, 5 minutes from my place, is to possibly be a patron, become a patron. You can do that through our website, and there are different platforms where you can become a patron, Patreon, Supercast. There are other options as well, and you can find out all about it on our website, spacenutspodcast.com. Although we do have a new URL. Apparently this is a URL, Fred, that is pretty becoming very popular at the moment, spacenuts.io. That's even easier than all the other stuff. Spacenuts.io is a new URL you can use to find us if you prefer. I mean, the other one still works as well, but spacenuts.io, and then just click on the supporter button, and that's how you can find out about becoming a patron or a supercaster or anything else. And while you're there, have a look around at our website. It's pretty schmick, pretty good. Now, Fred, let's move on to this discovery, I suppose you'd call it, on Mars. The InSight mission, which has been looking into Mars Quakes, has made a few discoveries there, but they've also made what I suppose you'd call a revelation about the core of the red planet.
Yeah, that's right. So you and I almost did a running commentary on InSight when they were trying to get that thermometer down into the ground. You remember the using the
they hit it with a hammer or something.
They hit it with a robot arm. That's right, to try and get this thermometer into the ground, which in the end failed. So one of the two main missions of InSight didn't really succeed, which was to get a thermometer, I think something like 2 or 3 meters below the surface, so they could measure the heat flow coming from the interior. I'm sure, knowing what NASA engineers are like, they've improvised at some level, and there are probably results that will come from that in due course. But what we have now is the results from the other major experiment that InSight carries, which is a seismometer. So it's been measuring Mars quakes. And most of what we know about the inside of the Earth, for example, comes from seismometry. It's the way earthquakes shake not just their location, but the seismic waves are transmitted through the rocks of the Earth and bounce off different layers deep down below the Earth's surface. So that's how we know about the mantle, how we know about the metal core that there is, because you get different reflections from all those things. And the same is true with the Mars quakes. And so InSight has, or the scientists, the InSight scientists have analyzed the seismic signals of, I think it's about 170, I think it's 174 Mars quakes. This is actually just 1 month. So they've got, it's quite it's quite a shaky place. Now, these are quakes that are at much lower levels than the earthquakes that we get on our own planet, but there is enough data in them for them to do this great job of working out where the reflections have taken place, what sort of time delays are involved, and it's allowed scientists now to probe the inside of Mars in a way that we could never do before. And the big surprise is that Mars has a metal core that is huge. It's much bigger than was expected. It's got a radius of 1,830 kilometers. That means it's 3,660 kilometers in diameter, if I'm doing my addition correctly, which is a sizable chunk. It's half the diameter of the planet, basically. It's much, much bigger than was expected. And that is really a surprise. It's what it implies is that the mantle, which is the layer above that, the layer of softish rock, plastic rock, is thinner than was expected. And they now have decided that mantle is made up of just one layer of rock, unlike the Earth, which has multiple. I think there are basically two layers of the mantle. And I think they're called, get this, Andrew, I think they're called the upper mantle and the lower mantle. There you go.
Yes, I believe so. I've heard that before. Yeah,
one's below the other, with the core in the center. So but it looks as though Mars has just got a single layer of mantle. The extraordinary thing about this seismometry is that you can actually work out what kind of materials are involved here. And so the core itself is molten iron, nickel, and other light elements like sulfur, which gives it actually a lower density, apparently. And that might be one reason why it's bigger than we thought it was, because you can kind of work out some of the internal structure of a planet by having spacecraft in orbit around it. That helps. And I think, but you've got to make assumptions about what the density of the various regions are. So I think people assume that the core was more dense than it was, and that would have led to the idea of a smaller core. If the core is lighter, then it's not surprising that it turns out to be larger. So, it's really, it's kind of revolutionized the thinking on the interior of Mars from the science that has been done there. One of the scientists is, and I hope I pronounced this correctly, Katerina Milkovic, who is at, I beg your pardon, Katerina, a planetary scientist at Curtin University here in Australia, who is involved with the InSight mission, and she's made some comments on the fact that the old ideas. She says the old idea is out of the door. These ideas about the thickness of the layers have really major impacts for understanding how processes are happening inside the planet. So we've learned a lot. It's really interesting. Another surprise is the crust. The crust of Mars is actually slightly thinner than was previously estimated. It's in the region it varies quite a lot, but between 24 and 72 kilometers are the figures that we're reading. So, yeah, really great stuff that we now have precision studies about the interior of the planet Mars. It's telling the story about the planet's structure that we really didn't know much about in the past. We had some idea of how thick the crust was, and there was a core, but these findings put a little bit more precision to where the layers are in the interior. That's Katerina again.
Yeah, it's prompting questions in my mind as you explain it all. They've discovered or detected hundreds of quakes on Mars through the InSight mission already. What is the cause? We know the planet does not have tectonics. So what's causing the quakes?
Some of it will be meteorites that hit the surface and with a thump. Because remember, Mars has got a much thinner atmosphere than the Earth, so there isn't the same kind of atmospheric breaking of a meteorite coming in.
Things come in hot.
They come in hot, high speed, land on the ground. There's a thud, makes a small crater. We see that happening, actually. We've seen craters being formed almost on Mars by these things. And that sends a seismic signal. But I think remembering now from, the early days of InSight, one of the things that scientists were saying is that there's probably just fairly minor faults in the rock of the landscape, and those faults slip from time to time. A bit like the faults on Earth, but of course the faults on Earth are primarily driven by plate tectonics. Here on Mars, they're just driven by probably long-term cooling of the crust, which is one of the things that we think happens on the Moon as well.
Mm. The other question that pops up is that the core of Mars they think is liquid, whereas the Earth's core is a solid.
The Earth's is two stage. There's a solid core in the middle, but the outer layer is, and this is the
exterior.
Yeah. So the reason why we have that on Earth is that the core of the Earth's core is big enough. When you think of the rest of the planet as well, that the pressure down in the center is very, very high. So even though you've got a high temperature, it's about 7,000 degrees at the center of the Earth, that compression by the layers above it is enough to force it to be solid. And so we have this solid iron nickel core with a liquid iron nickel core around it. And it's actually the dynamo effect of those two that gives us the magnetic field. Mars may not be like that. It might just have a liquid core.
Yeah, so a liquid core on its own just doesn't give them what they need to maintain an atmosphere, and that may be part of the issue.
Indeed.
Mm. And my final question from all of this is: could some of those Mars quakes be a consequence of something going on with a liquid core, or wouldn't they be related at all?
Yeah, that's a question I don't know the answer to. I would guess not, because I think the quakes, basically to get those readings from the seismometer, you've got to have things that are reflected around and pass through the rock. There may be, it's easy to imagine that at the boundary between the core and the mantle, which is probably a fairly slushy boundary, it's not just, at one point is liquid metal and a meter above it is soft rock. There will be a zone of differentiation. It's easy to imagine that there will be basically turbulence in that zone. There would be movement which might give rise to Mars quakes. So I don't know the answer to that, Andrew, but it's a good question, and I will try and find out.
Mm. Okay. That would be the goop zone, where the liquid and the solid, the goop zone. I think that would be what you'd need to call it, yeah. All right, fascinating findings. And, when I read the report, I was almost sort of thinking, no, that can't be right. The core of Mars being so massive, and yet it is, and it's a liquid core as well. It's nearly half the interior of the planet from what the report says.
Indeed, that's right.
Extraordinary.
I mean, there is another precedent for this, Andrew, in that Mercury also has a much, much larger core than anybody expected. It's huge. But that's a much smaller planet as well. And the thinking with that is that core would have been the core of a much bigger planet. So it would have had a much thicker mantle around it. But there was a collision in the early history of the solar system that stripped away the mantle and just left the core with this thin layer of rock around it. So another unusual world.
Indeed, very much so. Yeah, it's good to be able to learn something new about Mars because, as you and I have discussed, we've not really known much about what's going on inside, and now we've got some answers. So, yeah, I find it exciting. It's really good.
It is.
Really good. This is the Space Nuts podcast. You're with Andrew Dunkley and Fred Watson.
3, 2, 1.
Space nuts.
Thanks for joining us. Andrew Dunkley here with Professor Fred, and we've reached question time. Unlike question time in Congress or Parliament, this is a nice segment. And our first question, Fred, comes from 13-year-old Ollie in South Australia, who's emailed us a question. Hey, Fred and Andrew, my name's Ollie and I'm 13 from South Australia. That's a coincidence because I just said that. I have a few questions. I love this bit. I have a few questions for Fred to answer, and you, if you would like, on Space Nuts. Question 1. It is believed that the cause of the tilt of Uranus is because of something crashing into it or getting very close. If this was a rogue planet, where could that planet be now? Could it be on the other side of the galaxy or even in other galaxies? So that's question 1. I think we touched on question 2 fairly recently, but we'll go over it again. When we look far into the deep universe, the farthest thing we can see is 13.4 billion light years away, according to Google. So the light has taken us 13.4 billion years to reach us. Could there be things even further from Earth that we can't see because the light hasn't had time to reach us, or could they be too small to see? Could the James Webb Telescope help us with this? Love your podcast, guys. Listen to 2 episodes every night before I go to bed. Keep up the good work. Gee, thanks, Ollie. That's lovely. Glad you enjoy it. So question 1, Fred, what knocked Uranus on its back and is spinning on its bum, and where is it now?
So, Andrew, do you want to take this one or shall I?
I honestly have no idea. I'm sure we've talked about it before in the deep dark past, but
no, it was just that Ollie.
Something happened. Something hit it, and something, and it's instead of spinning like on a vertical axis like we have or near vertical, it's like that. So it's spinning like a barrel.
Yeah, there you go. So Ollie was right to give us the choice of who should answer the question. You've done a great job there. Thank you, Ollie.
Yeah.
Let's put a bit more detail on it.
Please.
Yeah, Uranus does spin. As you said, it's like a barrel. Its axis is tilted over by 98 degrees. So the axis points 8 degrees below the plane of its orbit, and that's why people say it's upside down, because its south pole is nearer the top, if I can put it that way.
I know there's a good book out there about this, Fred. I'm pretty sure I know a bloke who wrote a book called "Why Is Uranus Upside Down?"
Indeed, that's right. Yes, and I've never lived it down.
Who that was? No, it's a great title though.
Yeah. As I say many times, it wasn't my idea. Never mind. So the thinking is exactly as Ollie says, that this is the result of some sort of collision, or maybe a really strong gravitational interaction between our modern day Uranus and something else. And that something else is thought to have been a planet. Now, we're talking now about the very early solar system. We're talking perhaps within the first 200 or 300 million years of the solar system, when there was a lot of stuff charging around still. And some planetary scientists think that there was originally an additional planet in our solar system, probably out there in the depths of it where the ice giants, Uranus and Neptune, are. And it may well be that we know that planetary orbits migrate backwards and forwards on very, very long timescales, but we believe that that has happened. And in fact, some scientists think even that Neptune and Uranus used to be the other way around, that Neptune was closer to the sun. So if there was another planet there, that is, probably the origin of why Uranus is tipped over, if there was some kind of gravitational interaction between the two, and the most extreme gravitational interaction is a collision. So what happened to the other planet? Well, Ollie's question is a great one. It almost certainly has been ejected from the solar system. We would probably never be able to identify it. There are rogue planets out there that have been discovered, but one of the theories for their origin is that they've been knocked out of a solar system somewhere. But deciding whether one of the ones that's been found is anything to do with us is a different matter. One of the issues is so Ollie raised the question of whether it was on the other side of our galaxy or even in a different galaxy, I think is what he said. Yeah, the other side of the galaxy or even in other galaxies. And the answer to that is almost certainly no. And it comes about because the scale of the galaxy is so much bigger than the scale of our solar system. When we think of planets, we're always thinking in millions or billions of kilometers, and that is nothing on the scale of a galaxy. And the analog or the analogy I always draw, and it's just so mind-blowing, is if you imagine a diagram of our galaxy, a map of the galaxy, but instead of being on a piece of paper or something, it is the size of the Earth. Okay, you've got a map of our galaxy the size of the Earth. On that scale, the separation of the Earth and the Sun is 1 millimeter.
Isn't that amazing?
That just tells you. So think of 1 millimeter on this as compared with the size of the Earth. That's telling you just how much bigger galaxies are than solar systems. So even if 4.6 billion years ago, this planet got kicked out of the solar system, it won't be that far away on the scale of a galaxy. It's still wandering around somewhere on our side of it. Yeah.
All right. Here comes the curveball. Could it be Planet 9?
Who knows? That's a really good question. Planet 9 is still hypothesized as being this very distant object that is in a curiously elongated orbit. Yes, it's possible. And that's underlining what I've just said. It's not gone very far. It's still within our solar system. I think Planet 9 is proving extremely elusive. We really don't know whether it's there or not. Some scientists have come to the party and said there's no need to theorize that there's a Planet 9 because it's these elongations of the orbits of distant icy asteroids are basically illusory. It's just because we're not seeing all of them. So it's still in the melting pot, that idea. And I'm sure you and I will revisit Planet 9 at some time in the future, whether it's ruled out.
We haven't mentioned it for a long time, so I thought I'd better. But, it came to mind with respect to Ollie's question.
Yeah, it's still in it's still in the general melting pot of knowledge. It's certainly mentioned in my new kids' book, Space Warp. I've got a bit about Planet 9, not very much because there wasn't room for much, but it does mention it. So the idea is still there.
All right, very good. Thanks for the question, Ollie, and hopefully we answered it adequately. And thanks for listening. We really appreciate it.
Yeah, and the other part of Ollie's. The other part of Ollie's question.
There's part two. Gosh, I forgot about that. Sorry, Ollie. Yes, when we look into the deep universe and we see things 13.4 billion light years away, could there be things even further from Earth that we can't see because the light hasn't had time to reach us or is just too small to see? And could the James Webb Telescope help us with this? Yes, sorry, Ollie. Yes.
So just very, very briefly, because we've certainly discussed this before. Yes, there are. Yeah. There is in fact, there are multiple ones. There are horizons beyond which we can't see, and the most obvious one is the one that Ollie puts his finger on, that the light has not had time to reach us. So there are things in the distant universe that whose light hasn't reached us yet, and probably never will. because the expansion of the universe is carrying it, far faster than the light can get to us. And in that regard, the James Webb Telescope would be no help. We can't penetrate those horizons. So, it's a big universe, and we are only seeing what may be a small fraction of it. We really don't know how much of it we can see.
We can only speculate as to what is beyond the known universe or the visible universe. So, yes, there could be a heck of a lot more of it out there that we just don't know anything about. We just can't see it. But there you are. Ollie, thank you so much again. Let's move on to our next question from the United States.
Hey, this is Matt from Tennessee in the States. I just had a question about the Virgin Atlantic space flight that they just did with Richard Branson. So I was wondering if maybe y'all could do like a play-by-play or something of what's going on. One of the questions I had was, how far do they fall when they drop from the plane? Seems like that would probably be a pretty good fall. Also, why are they weightless for 3 minutes? Is it just because of the arc of the plane? Are they doing arc, or do they go straight up and then straight back down? I'm just kind of confused about some of the physics of what's going on in their short trip, and thought maybe you guys could explain a little bit. And thanks for all the questions you answer. I find it super entertaining.
Great. Thank you, Matt. Appreciate hearing from you, and lovely to hear your voice with that fabulous accent. Of course, Matt would tell you he doesn't have an accent, and we do. But anyway, lovely to hear from you. Yeah, I suppose we've talked about Virgin Atlantic and the Blue Origin launch and what they did, but we didn't really talk about cause and effect. So maybe we can analyse that a little bit.
Very happy to, yeah. So those two projects, Blue Origin's flights and Virgin Galactic, and we've seen them both in recent weeks, they're essentially both doing the same thing, even though the mechanism is very different. Virgin Galactic is basically being carried, you've got a rocket plane carried up by an aircraft to about 16 kilometers high, that's 10 miles. The rocket plane is dropped, and I don't think, in answer to the first question there, I don't think it falls very far. It's probably far enough that there's no risk of a collision with its mothership, because that would be a terrible thing. I would guess it is in the region of half a kilometre at most, because you don't want to lose the height. The rocket motor is switched on, and then they immediately overtake the aircraft because the rocket's accelerating much more rapidly. It's sloped upwards so that the flight is up, straight up and down. It's not a curved flight. This is not the mechanism by which these people are becoming weightless. That's different from the Vomit Comet, that aircraft that goes on a parabolic arc, and basically, it's what the astronauts have used for training for decades to give you an experience of weightlessness. This is a much more, in many ways, much easier to understand weightlessness. So both Virgin Galactic and Blue Origin, what you end up with is a rocket going vertically upwards, accelerating very quickly to about 1 to 1.5 kilometers per second. So that's 3/4 to 1 mile per second. And then the rocket motor, in both cases, the rocket motor cuts out. So what you've got is this capsule in the case of Blue Origin and the space plane in the case of Virgin Galactic, heading upwards at high speed under no other force than gravity. So it's slowing down gradually, and eventually it reaches the apogee, the highest point, and starts falling again. And then when you get much nearer the ground, the two become different again. Blue Origin slows its capsules down with parachutes. Virgin Galactic folds the plane in half that acts as aero braking, and it lands like a glider. But the important idea is that they're being shot upwards, and then all the forces stop. So you're in free fall, and that's when you become weightless for about 3 to 4 minutes in both cases. And the best way to illustrate this, Andrew, and it's something I used to do a long time ago, is if you jump on a trampoline. So when you're jumping on a trampoline, the mat that pushes you up is the equivalent of the rocket firing, And then when your feet leave the mat and you're in the air, you're in the same weightless state as these guys are in the space plane or the capsule. You're actually weightless until your feet touch the mat again, because you're in free fall. It's the same thing. You're going up and coming down. In fact, in both cases, what is really the case is you're in a really elongated orbit around the center of the Earth. It's so elongated, it's just a straight line. It's going up and down. As I always tell people, if you feel like getting on a trampoline, put a bunch of coins in your hand, and you'll notice that when you're off the mat, when you're jumping, those coins are weightless. They'll float off your hand. You're experiencing exactly the same weightlessness as you do in space.
I've actually done that, yeah. And of course, you can now experience what they do on Virgin Galactic and Blue Origin with a trampoline for a couple of $100 versus a couple of 100,000. So just bear that in mind.
Yeah.
I think that's an important detail. But what you're basically telling Matt, Fred, is that both of these vehicles, these modern-day vehicles, are going with vomit comet technology versus actually getting into space where they would be weightless. So that's the difference.
No, they're not. It's not. The vomit comet technology is different. That relies on an aircraft that is powered. So they're using trampoline technology to give them exactly the same experience as if they were in orbit. It's the same thing in orbit. Yeah, right. It's great stuff.
My first comment was right.
Yes, that's right. Whatever it was.
Yeah, I don't know. I shouldn't have tried to be too clever. But there you go, Matt. You do have your answer. That's the main thing. Eventually. Yeah. Okay. Thank you to Matt. Thank you to Ollie. And if you have a question for us, don't forget to visit our website on whatever URL you choose, spacenutspodcast.com or spacenuts.io. They all work, and click on the AMA link. And from there, you can upload your question via text or audio if you've got a device with one of these. That's a microphone. You can, most smart devices have them these days, and a lot of people have them built into their computers. So you can send us an audio question. Don't forget to tell us who you are and where you're from. And that bell earlier was someone at the front door of my office. So that's going to happen from time to time. And if they're impatient, it'll happen a lot. That brings us to the end of the program for another week. Fred, thank you so much. Good to talk to you.
Yeah, great stuff. It's always good to chew over these things. It's great fun. Thanks, Andrew.
My great pleasure. Our good friend Fred Watson, astronomer at large, will be back again next week. And from me, Andrew Dunkley, thanks for joining us on the Space Nuts podcast. We'll see you on the next episode. Bye-bye.
Space Nuts.
You've been listening to the Space Nuts podcast.
Subscribe to the full podcast on iTunes, Audio Boom, and Stitcher, or your favourite podcast distributor.
This has been another quality podcast production from Bytes.com.